We are now live, and now always the critical time when I share. Everything seems to be up and running fine. And sure enough, no results. What? Oh, here we go. Noel, I don't know what's going on. Let's see. Having the same kind of interesting issue here. Okay, here we go again, huh? Let's see what my task manager is telling me. Google Chrome not responding, which is not so good. Okay, so the first thing I'm going to attempt to do is I'm going to close Chrome. Hang in there. I'm going to come right back. Last time when I did that, it came back. Let's see if I can do that again. So here we go. Okay, can you guys hear me?
Yeah.
Yeah, I can hear you.
So now I came back. Now let me see if I can share. Here's always the critical point. Yeah, I don't know why the share screen button is like dead, and that's a problem. Okay, my apologies. I got to do the, I'm going to have to send you a new link. Well, I'll get going on it right away. Anybody still there? Try the same link. Okay, so let's go back to, and let's do 120. Send a message. Yeah, who's there?
Matt?
Hi. I take it you just tried the same link or what?
Yeah.
Good, because that's what I was just going to send out an email to do that. So hang on. I'm just going to try to email everybody to let them know to go back to the same link. It looks like sharing works now. So just a sec. Okay, now let's see if we get some more people in here besides you, Matt.
Want to be better. So I would want to find. Hello. What do you get?
So thanks for coming back. I'm just waiting for a few more people to join. Hi, Brendan. Okay, we got 3 of you. I'm just going to hang on a few more sec. And my screen share button appears to be working, so it should be good. Kirsten, welcome back. And the broadcast is evidently still recording. At least it says it is. I don't know how that. Okay, but whatever. I'm going to get into the sharing right away here. If I can, I got to figure out what else I need. Do I need to close anything here? I don't. Yeah, let's put that down. I need to reload my lesson because I got rid of that. By the way, typical. I had to reboot, and when I rebooted, of course, there was a Windows update that had to go in. So You know how that goes. At the least convenient time, that seems to happen. Okay, lesson loading. Lesson loaded. Now let's see if I can share my screen. Looks like I can. Okay, it looks like we're finally up and running, guys. You should see my screen now. Hide the participants. Off we go. All right, I hope you're, it looks like we had the 4 that we had originally. Now we're finally ready to go. Sorry, about a 15-minute delay there. So this is, as you know, lesson 3.1. It's actually called quadratic functions in the book. I shortened it a little bit and called it quadratics. You can see the 3 learning objectives there. I'm going to try expanding this. Let's see. Hopefully that'll work. It's a little bit bigger now. So anyway, the 3 learning objectives at the bottom there. Know how to analyze quadratic functions. We already started doing a little bit of that. Secondly, writing quadratic functions in the standard form, which I introduced you to yesterday. And then we're going to be doing some word problems. That's what the last one is. So I'm going to dive into a problem right away. And if you some of you may not have heard this when we were on before, but I was talking to you about how the it'd be nice to have your book handy today, especially on page 266. So this is number 24. I skipped some of the earlier ones because we've kind of already talked about that. You should recognize at the bottom of the page, I mean, this should look familiar, what I'm circling in red. That should look familiar from from yesterday. That's called the standard form of a quadratic. Do you guys remember what H and K stand for?
That's the center.
Yeah, so H comma K, not the center, you're close.
Vertex.
Yeah, H comma K is the vertex. Welcome back, Caitlin. Hopefully you're seeing the shared screen. And I guess that's the main thing, isn't it? And A, you know, if, let's just make this comment about A. A tells you if it's what? Right side up or upside down. If A is positive, it's right side up. If A is negative, it's upside down. And if A is a big number, then it's stretched upward. If A is a fraction, it's like squashed vertically. Yeah, so that's pretty much review. So now look at number 24 at the top. Okay, that's number 24 from the book. And the directions are, sketch the graph of the quadratic without using a graphing utility. So in other words, just using algebra, can you come up with what the sketch of this thing looks like? Well, the key is to get this thing into that standard format that we have at the bottom. We did one kind of like this yesterday in class. Let's see, I take my keyboard off so I can draw a little bit better. So what we need to do here is, I'm changing the blue. What we need to do is rewrite this and try to get it into that standard form. And so what I'm going to do is, I'm just going to spread it out a little bit. And what I usually do is keep the x's by themselves and kind of move the constant out to the right a little bit. And then we need to complete the square over here on this x stuff, but we can't do that with that negative there. So I'm going to take a -1 out. And then this reads what? X squared plus 4x. So we're just leaving the +1 out there. We're not factoring out of that. So hopefully everybody sees what I did up to that point. All I did was factor it. And now I'm set up in parentheses to complete the square. We need to look at that b term right there, the 4. Half of that is 2, and 2 squared is 4. But because there's a -1 outside the parentheses over here, I just really subtracted 4, didn't I? I mean, remember, everything in parentheses has to be multiplied by -1. So in effect, when I put this in, I subtracted 4. So to compensate for that, I subtracted 4. Of course, I can't just change it. I have to add 4. Now, we're in good shape because now I can write this thing in parentheses as a perfect square. Remember, square root of x squared is x, square root of 4 is 2, sign from the middle, plus. And now if you look, we got it. This is good old standard form, isn't it? If you look down below in the red circle, we've got it matched up. You can see, first of all, this is a good old quadratic parabola. But instead of facing up, it's facing down, right? That's what that negative tells me. And instead of being at the origin like it normally where its vertex is, it's now what? Shifted to the left 2 and up 5. And it's standard width. It's just upside down. All right. So let's see. If I scroll down, I mean, here it is. I've gone to the left 2 and up 5. So if you look, 2 to the left, up 5, we're sitting right there. Yep, that's the vertex, and it's upside down. Yep. And now we could sketch the graph. If you really want to get technical and you really want to know, let's say, the right width, where are these two x-axis crossing points? How could we find those? Just change y to 0, and you could solve. But anyway, that's really, so the main purpose of this is, given any general quadratic, you should be able to convert it to this red circled standard form on the bottom. And then you can find out, all right, does it open up or down? Is it skinny or chubby? Has the vertex been moved left or right or up or down? And pretty much you're set to go. That's the idea of that section. Let's take a look at another one from that same section. And again, toward the bottom, let's see, you can't quite see it because I've got it a little bit too chubby, but if I scroll down, just a reminder, when you get the standard form, it looks like that. Some constant a multiplied by x minus or plus h squared plus k, where h comma k is the vertex. And yeah, so let's just take a look at number 26, do the same thing we did with 24. Obviously, it's not in standard form. So let's get it there. I'll switch to black here. So we're going to split the 1 off to the side again. And we'll just write it with just the x terms. And now I can't have that 2 there, so I'm going to write this like this, 2 times the quantity. And now be careful. X squared, what, minus 1/2 x? Do you guys see where I got that negative 1/2 from? Because if you multiply this out, 2 times negative 1/2 x equals what? Negative 1x, which is what it was in the top line. So if there's a little bit of a tough maybe step, it might be that one. Okay, now we're ready to complete the square. The b term is 1/2. What's half of 1/2? 1/4. And then what's 1/4 squared? 1/16. So that tells me 1/16 is the perfect number to make that into a perfect square trinomial. But I put a 1/16 in there. What did I really just add? I added 2 times 1/16, which is 1/8. So I have to subtract. So because I added 1/8, I must also subtract 1/8. All right, now we can write this set of parentheses as a perfect square. I guess before we do that, should we combine this 1 minus 1/8? 1 is what? 8/8? And 8/8 minus 1/8 is 7/8. Okay, and then this is a perfect square trinomial if we did it right, and we did. The square root of x squared is x. The square root of 1/16 is 1/4. And the sign from the middle this time is negative. We've done it. We've got it in standard form. So, what's the vertex of our parabola? It should be this time what? What's being subtracted from x? 1/4. And the K tells us, so there's the vertex. Is it opening up or down? Up, because this is positive. And because that's a 2, it's stretched upward. So we pretty much are ready to go ahead and do graphing again. Okay? Let's see. Let me just write this one down real quickly on a piece of paper, and then I'll just quickly do it in Desmos just to confirm. So we have 2 times x minus 1/4 squared plus 7/8. So in Desmos, let's see what I got here. Desmos. Oh, here we go with the keyboard again. I got to learn how to use the non-keyboard, the other keyboard. But anyway, now I want to do 2 times x minus 1/4 quantity squared. Oop. Go to the right there. And then we've got what? Plus 7/8. So I know you're not going to, you're only going to, whoa, excuse me. So there's our vertex. Sure enough, we're to the, you can tell by kind of, it's 0.25 is 1/4. So we are 1/4 to the right like we thought. And we're up, that 0.875 is 7/8. And it is steeper. So just a confirmation. Okay, go back to our file here. Okay, so hopefully those two make sense. Now, we're going to jump ahead. I want to jump ahead to a new section on the assignment. We're going to take a look at number 33. Okay, number 33. And the directions change now. It says, use a graphing utility to graph the quadratic. Identify the vertex and x-intercepts and check your results algebraically. So, there's our function, 2x squared minus 16x plus 31. Again, it's not in the right form. So I split 31 off to the right, and I factored a 2 out of the x guys there on the left. That left me with, in parentheses, x squared minus 8x. So, Kirsten, I hope you're not having troubles. I see you reconnecting. Thank you for reconnecting. Sorry about the nose blow. Okay, so I factored the 2 out, and then I completed the square. Inside, we had this 8 right here. Let's see if I get my pen going here. So we had this 8 right here. Half of that 8 is 4. 4 squared is 16. So I added 16 to make that a perfect square trinomial. But because there's a 2 out there, I just really added 2 times 16. I just really added 32. That's why I had to also subtract 32. All right. So now we've pretty much got it. What is this trinomial as a binomial squared? Square root of x squared is x. Square root of 16 is 4. Sign for middle, minus. And then 31 minus 32 is minus 1. So, well, you can see now we have standard form. This is a good old parabola. Opens up, because that's a positive there. Its vertex is 4 to the right and down 1. And if you look, I've superimposed the graph on here. See how, I don't know if you can tell, but it's over 4 and down 1. You can't see the down 1, but the vertex is there. So anyway, how could I find out where it crosses the x-axis? Again, I could set it equal to 0, like you see I did in green here. And then you could solve, and you can come up with these 2 answers. By the way, 1 over the square root of 2 is about 0.7. So when you look for the plus answer, it's 4 plus 0.7. And if you look right here, right there, sure enough, that's at about 4.7. And when you take 4 minus 0.7, it's 3.3. And sure enough, that's where the other intercept is. So if you want to be real nice and accurate about how wide the parabola is, you can always find the x-intercepts. Now, you guys have learned how to do that a bunch of times before this. We've done it a whole pile of times this year. So anyway, so where did I get, somebody asked me, where did I get the number negative 32 on this problem we're working on right now? Let me just say again. So up here, I'll use red this time. Hopefully you saw that I factored a 2 out of this thing right here. And then, all right, at the moment, let me do this over. This was blank, right? Here, I'll erase that too. So this was blank. So I just factored a 2 out. All right, the 8 is the B. That's the thing we have to complete the square on. What's half of 8? Half of 8 is 4. What is 4 squared? 16, right? So I plug in a plus 16 here, but that plus 16 is being multiplied by 2. Remember, it's in parentheses. What's 2 times 16? 32. So if I added 32, I have to get it back to where it was by subtracting 32. So hopefully that answers the question. Somebody who sent me a text message down there. So I'm going to get rid of that text message. All right. So anyway, that's number 33. We've seen that one now. 34, I don't know. Let's go to 36 next. Okay, number 36. Now, I'm not going to redo this, so hopefully you can follow what I'm doing here. The same section, it says, can you turn this into standard form, first of all, and then plot it? So, if you look at number 36, there's a 3, they've already got the 3/5 factored out. Does everybody see that? So that gave us I don't know, made it a little easier. All right, but watch out, there's one pitfall here. So let me backtrack a little bit. This is actually not there, right? So if you take, all I did was take the -5 out of here. Well, if I take the -5 out, it's actually 3/5 times -5, right? You can never separate a number in parentheses from what's being multiplied by it. It's called the distributive property. So if I'm going to remove this out, I'm not removing 5, I'm removing 3 times -5, which is -3. So that's where I got this guy from. Okay, so when I took this -5 out, it has to be a -3 because it's not -5, it's -5 times 3/5. You know, I can never forget about that multiplier. Now I can complete the square. Half of 3 is, I'm sorry, half of 6 is 3, and 3 squared is 9. So what did I just add? I added 9 times 3/5. What's 9 times 3/5? 27/5. So if I added 27/5, I have to right away subtract 27/5. Okay, well, the good news is that did it, because now this is a perfect square trinomial. I can write that as x minus 3 squared. Then I just combine these two. -3 is what? -15/5. And -15/5 minus another 27/5 is -42/5. And then you can go ahead and do the graphing. So, I mean, this is a parabola. It opens up. The vertex has been moved to the right 3 and down, what is that, a little bit over 8, -8 2/5. So to the right 3 and down a little bit over 8. See that? To the right 3. There's 3 would be what? Right here. To the right 3 and down, you know, a little bit over 8, and sure enough, there's that vertex. Okay. So we're just trying to get you guys. So, you know, what we're doing is practicing completing the square again. And we've got to watch out with those. We got to always kind of have care with the parentheses. I see Kirsten. I'm sorry, Kirsten. Now that I've restarted, of course, she's got problems. I'm sorry, technical difficulties with her, but I'm assuming everybody else is up and running. Let me just take a peek here. I'm going to take a chance and turn on. Yeah, we got everybody else's picture is there, so that's good. Okay, so it looks like Kirsten is the one having technical difficulties. I hope not anybody else. All right. Now, let's jump ahead to a new section. We're going to go to number 45. New set of directions on the assignment, number 45. So here's what it says. Find the quadratic function that has the indicated vertex and whose graph passes through the other point. Caitlin left and came back. I hope you're okay out there. But anyway, so we've been given this vertex, 3, 4, and that means what? They gave us h and k, right? And we're going to use this later. So first of all, let's get started here. If they gave us the vertex, we don't know what A is, but we do know this. So we should have y equals A, and now they gave us x minus 3 plus 4, right? So you see how I put the h and the k in there? The 3 and the 4. But I don't know, this is missing. Do you see that? I don't know what A is, but this is the big clue for finding it. They gave us a point that works. So what do you do anytime in algebra they give you a point? You substitute it in, and that will allow us to calculate A. So taking my keyboard off again so I can draw a little bit better. Here we go. So I'll switch colors to black, excuse me. So y according to the point over there, is 2, right? That was 1 comma 2. Y equals A. And now we're going to plug in x. 1 minus 3 squared plus 4. Okay, 1 minus 3 is negative 2. And what's negative 2 squared? 4. So we have 4a plus 4. Right? Negative 2 squared is 4. And a times 4 is 4a. Okay, so now all we got to do is solve for a. Subtract 2 from both sides. And then divide both sides by 4. So do you see that that's what a is? So now just come back. I'll change the blue again. Now just take this equation and rewrite it with the a. Negative 1/2 times the quantity x minus 3 squared plus 4. And that was the goal, to find the quadratic function. I suppose I could have put f of x instead of y, but so let me just pause a second. Any questions? Any questions on 45? Do you see what I did there? So this time they gave you a clue that allowed us to find the missing thing. In this case, the missing thing was a. The clue was that point that it went through, 1 comma 2. Looks like Caitlin's having trouble. Sorry, dog is crying. Come on, doggy. We'll try this with the dog on the lap. All right, so let's do another one of these. How about, let's take 52. 52 is from the same section. All right, number 52. They gave you, the vertex was 6, 6. So do you guys see why? Here's where I put the 6, 6. Do you see that? That's the H and the K. What's the matter, little peanut? What's the problem? Okay, so do you see how I stuck that in? And again, I don't know A. All right. Now, so ignore this for the moment. That's the answer. Okay. But come down here. So now I just plugged in the point. Here's the clue. They gave you a point that it goes through, and that's your x and y. So x is 61/10. See, I plugged it in right there. And y was 3/2. See, I plugged that in right there. Well, that should allow us to solve for a. And that's exactly what I do in the next few lines here. I mean, I'm not going to, you guys can go through, that's algebra 1. I don't think we have to go through. But anyway, a turns out to be negative 450. So then I just came back up at the top and I stuck, right, I just stuck the negative 450 back in. Caitlin, I appreciate you and Kirsten trying to keep connecting. I'm sorry you're having trouble. I don't know. Looks like, I hope nobody else is having trouble with that. All right. So this is what we were trying to find, the function. We found it. So there's a couple problems of that 43 to 52 type. Now I'm going to go to 66. This is yet another type of problem, number 66. This time, this time they're telling us, here's the directions. Find two quadratic functions, that one that opens up and one that opens down, that crosses the x-axis at these 2 points. And here are the 2 points up here on the top. So you can, here, put the dog down for a minute. Just picture this. So if you have a grid and you got negative, let's just say negative 5, 0 is there and positive 5, 0 is there. They're saying one parabola crosses and opens up like that. And then you got another one that opens down. So do you see how there's always two parabolas that will have the same two x-intercepts? Find the equation of those two. That's the goal. Okay, so we got to be a little creative here and think backwards. So if the two x-intercepts are -5 and 5, then doesn't that mean this? I mean, think backwards. Remember in your older problems, isn't this how we found the x-intercepts? We factored it, set the two factors equal to 0, and then solved. And what would you get? You'd get x equals 5 and x equals -5. Oh yeah, those are the points we had. So now in reverse, I'm doing it, I'm saying, all right, so it had to come from that. Well, what's x minus 5 times x plus 5? Well, that's just x squared minus 25. Can I write that in standard form? Sure, it's x minus 0 squared minus 20. Ah, there's the right side up answer. And is it possible that both of those could be negative? They could be. That's the other factor. And so you notice I put a negative here. And I also took the opposite sign of that. And sure enough, these are the two graphs. Found the equations of the two. Now I know the x minus 0 is kind of a waste. You could just call that x squared, but I'm trying to show you standard form. I guess let me show you in Desmos that that really works. Okay, so put my keyboard back on. Trying to find Desmos. Hang on. There we go. Okay. So one of them was what? X minus 0, quantity squared. And what was it? Plus 5? My memory is failing me. No, minus 25. Okay, minus 25. So there's that one. And then the other one was what? X minus 0. Oh, negative. Negative on the outside of the parentheses. X minus 0, quantity squared. And this one was plus 25. Now, let me just shrink that. And you see that's exactly what we got. Both of these cross right at -5 and plus 5, just like they said. And one opens up and one opens down. So you see we got the right answer. We got the equation of the two parabolas that open up or down. So, okay, let me head back now. All right. So these really are the two answers here, 1 and 2. It said find the equation of the answer. Let's see. Let's do another one of those. Let's do 69 this time. Okay, number 69. So this time they gave us these 2 points. So not quite as easy. Instead of -5 and 5, this time we have different numbers. Well, that had to come from this. Why? Because remember, if you have 0 equals that, the 0 product theorem says, okay, that means x plus 3 is 0 and x equals -3, just like it's set up here. And if you set x plus 1/2 equal to 0, that would be x equals -1/2. So it had to come line equation. Okay, well, multiply that stuff out on the right and you get this. And when you simplify, you get this. Okay, so we've got at least one of the functions, the right side up one. And then what I did is I just put it in Okay, so now I did the old completing the square thing. Here, let me erase, I'll show you. So if you look, this line is the same as the one right above it. And I factored it. Good news, we don't have any numbers sitting here on the X, so we don't have to worry about that. So take half of the B. What's half of 7/2? 7/4. And what's 7/4 squared? 49/16. And I have really good news for you. This time there's no number out here, so it's just it's just a 1 times. Okay, so I don't have. I mean, we really did add 49/16, and so now I have to subtract 49/16 because you know we've added it and subtracted it. Now this is a perfect square trinomial, and it's factored as x plus 7/4 squared. And then I just combine these two over here. Okay, so now we've got at least the right side up one. There's the right side up one, and then if we just take the negative of the x part and the opposite of the other part, there's the other one. Okay, so there's 2 examples of the part from 65 to 70. All right. Yeah, let me show you a couple slides now. Just to kind of wrap things up, and then we'll hopefully we'll just do a word problem, and then we'll get out of here. Sorry I'm a little bit late today. Hope that's not causing you class problems. So just a quick review of some things. We all know that, I mean, this thing right here is called, this is the general form of a quadratic, just good old ax squared plus bx plus c. And when you plot a typical parabola, it looks like this graph here, and we want to know the equation of, you know, that this is called its axis, and this thing right in green right here, that's the vertex. All right, we know that. We know that if A is positive, the parabola opens up. If A is negative, the parabola opens down. So that's totally review. I won't spend too much time on that. And we know that if A is big, it means it's stretched, more like the green curve. And if A is a fraction, it means it's going to be like sat on, kind of like the blue curve. So that's all review. And what if H and K are moved? Well, that just means the vertex is shoved around. So like if you look over here in the blue, the vertex is obviously what? Moved to the right 3, and sure enough, look at the graph. The blue curve is moved to the right 3. Up here, the green curve is moved to the right 3 and shoved up 2. That's all review. So quick review on that. And now this part I hinted at last time, yesterday in class. It's always true that the vertex will be low. You know, if you take a standard quadratic like 3x squared minus 4x plus 9, the vertex will always be located at the box x equals minus b over 2a. So if you take that equation right down in green, b is -4, right? Sitting right here. So minus b is +4 over 2a. 2 times 3 is 6. So that tells you the equation vertex every time. I'm sorry, not the it tells you the x-coordinate of the vertex, but it tells you the equation of the axis of symmetry. And the vertex is always on the axis of symmetry. See that? Look up here. The axis of symmetry is this dashed line up here. And where is the vertex? Of course, it's right on it. Okay, so that comes in very handy, this box equation here. You want to make sure and put in your notes. If you need, that'll give you the x-coordinate of the vertex, and it'll give you the equation of the mirror line, the axis of symmetry, every time. So this is just a practice of that. Here they gave us this, they gave us this equation right here. X squared plus 6x plus 7. Where's the vertex? Minus b minus 6 over 2a minus 6 over negative 2 is plus 3. Sure enough, look. The graph, where's the axis of symmetry? Right at 3. Okay, so that means the x-coordinate of the vertex must be 3. What's the y-coordinate? Well, that's easy. Just plug 3 in, and you'll get it. Negative. So if you take 3 squared is 9, negative 9, and negative 9 plus 18 is 9, and 9 plus 7 is 16. Yep, that's the y-coordinate, 16. So, okay, that one, that's similar to what we did earlier. Let me just show you a word problem where we make use of this, and then we'll hang it up. Okay? This is number 75. I should write that on here. So if you look at number 75 in the book, and that would be on page 268. So here's the deal. It says, a rancher has 200 feet of fencing to make a pen, 2 adjacent rectangular corrals. They have a picture in the book. And so what I've done is just kind of make my sketch of that picture. Okay? We know that the total is 200 feet, and those 3 vertical lengths are the same length. So I call them all X. Do you see that? There's 3 that are the same length, X. Okay, and then I know that I've got 200 feet, so it's like 200 minus 3X. But then there's 2 sides like that, so I have to take, here, let me just write that down. So it's like 200 minus 3X. But because there's 2 equal sides, I got to divide it by 2. Well, what does that become? 200 divided by 2 is 100. And 3x divided by 2 is 3/2 x. So that's where dimension from. Okay, so now the question is, write the area of the corral as a function of x. How do you find the area of a rectangle? Length times height. So take that length, 100 minus 3/2 x, multiply it by, here's the length, and here's the width, x. So I multiplied it out, simplified it. There she is. That's the equation of our function. Does that look, I don't have it in standard form, but we could easily get it there. They didn't ask for that, though. So what do you think will give us the maximum area? Well, guess what? It has to do with the good old axis of symmetry. So in this case, what is B and what is A? Well, B is sitting right here, 100. Minus B over 2A. If you take negative 3/2 times 2, you get negative 3. There it is. That's your perfect X size to get the pens with the biggest area, so that whatever you're going to put in the pens has the maximum amount of space to move around and to live. And then down below, that leaves 66.5 for the length. But I think so the dimensions that'll give you the best, well, it really comes down to this. And then that leaves this for the length, just by substitution. Okay, so in other words, what they've done is they've got word problems that come out to quadratics. And what are we studying? Quadratics. So let me get to the assignment here. By the way, this is a little different from what's on the website, so make note of this. I've got 3 sections of odds I'd like to give you. The first section is These are all ones we took, we at least did an example of today. The first one is from 1 to 27, do the odds there. Then we're skipping to 37, and from 37 to 51, do the odds there. And then we're skipping up to 71, and from 71 to 77, some of the word problems, just do the odds there. So that's what? 71, 73, 75, 77. So there's 4 problems in that section. You'll see there's not actually that many problems here. Okay, that'll be our assignment for next time. Now, I maybe rushed it a bit because I started late. My apologies for the technical problem again today. Thanks for hanging in there, you 4 that were live. Are there some questions you would like to ask?
Do all the word problems reflect kind of what you did in 75?
Well, they're very geometric in that regard. I think you're going to see, yeah, I don't know. I can't say they're all exactly the same, no. But
Okay.
a number of them are. But they all, guess what? They all involve a quadratic.
Okay.
And so the whole idea here is these are word problems that come out to quadratics, just like what we've been learning about in the lesson.
Okay.
Anyone else have any questions? All right, thanks a lot. Thanks for hanging in there. Sorry about the delay. Look forward to seeing you tomorrow. Thank you. Ending podcast.